All right, welcome back everybody to day 15 of Foundations of Programming. Pretty crazy day 15. We are uh about to complete three-fourths of the program. All right, next week will be the last week of Foundations of Programming. And then the week I said you guys start the immersive program. Isn't that cool? Um, so right on. We might be expecting one or two more people in today, hopefully. But if not, that's okay. We're gonna go ahead and just pick up from where we left off yesterday. Yesterday we had started Space Invaders with Pygame using object-oriented programming. We went through the installation of Pygame. We talked through virtual environments. We created a virtual environment for our project. Um, we activated our virtual environment, and we started working with some Python, right? We were able to create our basic window. We had our run method that essentially has this loop that we are able to continuously run. And this loop is checking for different events within our program. We were able to check for keys that are being pressed. And then throughout every single iteration of our loop, we are updating our screens with the most recent version of like our screen and our surfaces, right? Uh, Very straightforward. We were also able to take care of our class spaceship, which has an image and a rectangle for collisions. We had a get position method and a get image method. And I think the last thing we worked on yesterday was the move method, right? Um, the move method was able to function by using the pygame.key.getPressed method that returned to us essentially a dictionary in a sense of the status of every single key on our keyboard, right? This dictionary held a status of either true or false, depending on whether a key was being pressed or not. And we use that to our advantage to check a specific key, whether W, A, S, or D, to see what direction we were moving. And depending on which key was being pressed, we call the self.spaceship.move method that belongs to our spaceship object that takes in a string. That string is taking the place of our direction argument here, which we then use to increase our x-axis, decrease our x-axis, or increase or decrease our y-axis, therefore making our spaceship move, right? Um, pretty pretty simple. We didn't go too in depth about anything of these actual methods, right? Uh, no actual learning of Python here, just really leveraging the spaceship, right? So uh, up to this point, we are starting to see how our objects are actually coming to life, right? I've used the term instantiate, right, which is the creation of an instance of an object, right? The creation of an object, right? Um, that the time frame of that object being, you know, alive or existing in our project is called the instant, right? That's the lifespan of that object, right? That's when we bring our object to life. We were able to create a game object, right? This game object essentially holds a couple variables, which was the settings of our display. We had our clock, which was tapping our frames at 60. Within this object itself, we were also able to create, surfaces. We were able to save the image of the outer space. We also create an object within this object, right? The moment the game instance is instantiated and it runs the init method is also in turn instantiating a spaceship object, right? So actually, two objects are being created at the moment of creation of game, right? Um, Now we are going to include a new object into our program. Let me get my dog out real quick because he's getting anxiety. Sorry for that. He likes to come inside, and then when he's in here for too long, he's like, "Oh, let me out," and then he wants to come back inside. They're annoying, man. They're kids. Uh, but what you call it? So we're going to introduce a new object today, which is going to be our bullets, right? With a bullet class, we're going to see objects really shine, right? Because in this situation right now, we only have two different objects, which is the game and the spaceship, and that's it. No other object is being used. Uh, and one of the cool things about objects, and one of the biggest reasons why we use stuff like objects and functions, is to have the ability to reuse our code, right? Um, so with that in mind, we're going to create a bullet class. So just like we did yesterday, where we created a spaceship file, we are going to create a new file within our lesson 10. And we're going to call this bullet.py. Make sure you guys are also following along. Do not forget to initiate your virtual environment. If you need a quick refresher on initiating your virtual environment, you want to use the command source. And then you're going to put in the file path of where your virtual environment is located at, followed by bin, followed by activate. And that should activate your virtual environment so you can actually run your Pygame. Right? So with this new bullet class, just like spaceship, we are going to import Pygame. We're going to define our class bullet, and we are going to give it a constructor. Now, our bullet, we want to be able to press a key or maybe the mouse button, and then when we press this mouse button, what should happen is, as we already expect from something that fires, like a cannon or a spaceship, a gun itself, you want to exit a bullet out, right? So as it stands, a bullet doesn't exist until we press a button. The pressing of this button should be able to create an instance of a bullet object, right? Which is going to represent that specific bullet that comes out of our weapon and is going to shoot out through our screen. So at the click of a button, I need to be able to create this bullet. What type of arguments, without you guys looking at the README, what type of arguments are we probably going to want to give to our bullet class?
Kind of similar to the spaceship's direction. So we want to pass in a like click or shoot function, I guess you'd want to say.
Current location of the spaceship.
Yes. At the end, it will have to be the location of the spaceship. But that's kind of what I was looking for, a location, right? When we create our bullet, we want to make sure that we can give a location of where it should be created at, right? The same way when we created our spaceship, we give it a location. Same concept with the bullet. Now, the bullet class is going to be a little bit different from all the other classes that we did. It's not going to take an image. If you notice throughout your assets folder, there is no image in your directories for a bullet class. The reason for that is because I couldn't find a good enough picture that I like for the bullet. So I took another method on creating the bullet. And the method of how we're going to create this bullet doesn't really matter. It's just an alternative. Instead of loading in an image, you're able to create a shape with Pygame that you can use. So we're not going to have to pass in any kind of image file path, right? All we're going to do is pass in an X and a Y axis. X and Y. Now, when this bullet method is called, the init method should run and should construct my bullet. So my bullet should have a couple things. Well, it's going to have uh first and foremost, as we already saw with the spaceship, we needed some kind of image or shape or some kind of actual body for it, right? And then we need a rectangle to handle the collisions as well as how we're going to move and orient our bullet, right? So we have to do these two things. Now we don't have an image, so we're going to manually create uh, this bullet using a Pygame method that you don't have to memorize, right? I provided it to you for for free. So we're gonna say Pygame dot. Oh, I take that back. We're gonna say self dot image is equal to, right? This is the data member that's gonna hold our image. Now to create this shape, we're gonna say Pygame dot surface with a capital S. And we're going to pass in the dimensions of this surface, which really it's going to be a shape. And because it's going to be a bullet, it's going to be something very small. We're just going to make it something very small, like 10 by 10, right? 10 pixels by 10 pixels. So 10 comma 10. Now, you see this command before. We are essentially creating a surface, right? You saw before when we created the surface where we were adding the space picture and the picture for the spaceship, right? We used this surface, but we only passed in one argument, which was the dimensions. We're essentially leveraging the surface command to create a shape, right? By default, this is a square, right? As you saw with the surface. But we're going to manipulate this surface and we're going to make it into a circle. And to do that, we're going to pass in a second argument. Because our bullet needs to have a very specific surface. We want to make sure that our surface is the same shape as our bullet. So we're going to say Pygame dot src alpha. This is going to create our surface for our bullet. And now we're going to draw the circle in it. We're going to say Pygame on the next line. Pygame dot draw dot circle. Now this circle function is going to take the surface that it's going to be added into, which is going to be self.image, right? This is the surface that we just created, self.image. The next argument is going to be a tuple. And this is going to be the color, right? What color do you want your bullet to be? We're going to make it red. And it uses the RGBA combination, right? If you guys recall from CSS, red, green, blue, and then the A was like opacity, I believe. So we're gonna say 255, comma 0, comma 0. Actually, I don't think the fourth one's opacity for this one. I forget what it is. Just know that this is gonna make it red. All right, that's all that really matters here. It's gonna make it red. And after we give it color, we're going to give it its dimensions. We're going to say 5, comma 5. And I think the fourth argument is a radius. Let me see. Let me hover this. Oh, it's not going to show me. Okay. Put 5 here. And I can show you what exactly this is doing. Pygame dot draw dot circle. Okay. We're going to go to shapes. Where are you? Where are you? Pygame dot draw dot circle. All right, here's a much better way of explaining this. We have the surface, the color, the center, and the radius. There we go. These are the actual arguments that they're taking and what they are. The surface here, surface to draw on. The color, you can either specify color here, or you can pass in a tuple, as you see here, which what we did. So I guess you can just type in red if you want to, or you can just use what we used, which was that tuple. And it does use RGBA. I was correct. See, I shouldn't doubt myself. Next is center, which is tuple as well. Int, or our list. We could pass in the list too if we wanted to. The center point of the circle as a sequence of 2 integers. Okay. We're essentially grabbing that surface and putting the circle in the center. 5, 5, right? And then the radius of the circle. Awesome. Finally, we're going to say self.rect, right? We have to give it a rectangle just like we did the spaceship. We're going to say self.image.getRect. And this one, do we want to use mid-bottom? Yeah, we'll use mid-bottom. It'll make it easier to orient it to the canon of our spaceship. We're going to say X, Y, right? Because we're going to use the mid-bottom. That's where we're going to pass in our coordinates so we can orient our bullet right at the tip of our spaceship. All right. Now, there's something that I skipped here, but we're going to come back to it later for a reason. But as of right now, this should be fine to continue with for now. For an example, I guess, right? So how should this work? When we click a button, whether it's a space bar, whether it's a mouse key, we want this to create a bullet class, right? What problem do you think we could encounter with this class as it is right now?
I'm thinking the bullet doesn't disappear after a set time, or
Yes, that is one issue, right? That's a good point, Michael. That one will be covered too, but that is one. Daniel?
You might only get one bullet.
I might only get one bullet. Yeah. Which opens the conversation to where I was trying to lead to. When you shoot, right, in a game, whether it's Call of Duty, Fortnite, whatever you like to play, right, whatever makes you happy, how many bullets are there at a time, right? It's not just one at any, at a specific time. It's usually multiple, right? You're probably holding down your mouse button and it's just shooting, right? You typically have multiple rounds, especially if you play games like I think Fortnite does really well at showing you the bullet trajectory. If you play games like that, you could probably typically see the bullet trajectory depending on the game. If you played stuff like Battlefield, if you use a sniper class, you can see the bullet drop. Tracer rounds, you can see that. So you can see that there might be multiple bullets that exist. How can we move multiple bullets at a time? Well, the easy answer is you're going to want to update every individual one, right? When you create a bullet object, right? When you fire your weapon, we're going to create a bullet object. And every single time we fire, we're creating a new one. But we also have to make sure that each individual bullet is being updated every single time that our while loop is running. How do we keep track of so many bullets? Now, we could manually hardcode this, but we don't have to. Pygame and like many other game engines, they provide methods to do this. Uh, and the method for Pygame it's called a sprite group, right? What a sprite group essentially is, it's a built-in it's a built-in class that allows you to store multiple objects within it, right? And then update all the objects that are within this object. Now, what does that look like, Roger? Well, if we didn't have this method, I would have to hard code something like this, where I would say class, all bullets, right? And this class, the only purpose for this class would be something like self dot bullets is equal to let's go with a dictionary, or we can go with a list. Yeah. And every time that when we fire, we create a bullet object, right? We might want to have something like create an all bullets class. So we might create an all bullets class. Then when we fire, we're going to create a bullet object, add the bullet object inside an all bullet object. Right? So every time I create an instance of a bullet, I might want to be able to add it within an object that can hold multiple different other objects, like this one. I can see something like add bullet. And this takes a bullet object. Think of cells for day, right? Think of eliminate stand, right? When you created a cell for day record, right? You save that into your cells record of eliminate stand, right? So eliminate stand was essentially one big object that was storing a list of cells for day objects, right? That we could then manipulate. That's kind of what all bullets is doing here. We would have to create a class here that we can use to keep track of every bullet object that we create. And it would have a method like add bullet, where we would say self dot bullets dot append bullets, right? So we would add the bullet object inside of all bullet object. And then every single time our game was running this loop, we would leverage this all bullet object here and maybe call a command like update all bullet dot update. And what update could do would go through every single bullet within here for bullet itself dot all bullets, bullet dot move, and bullet might have a function called, if we're only making the bullet go upwards, then we're going to subtract the y-axis. So we'll say self dot rect dot y minus equals 5, right? So we might have something like this, right? Where all bullets is able to store every single instance of a bullet. And we're able to add things to this all bullets data structure. And when we run the update method, is going to manually go through every single bullet that we have and make sure it gets moved a little bit further, right? This is one way that we could manually hard code this to ensure that we can keep track of multiple different objects. And we saw this already in eliminate stand.py, right? Well, I don't have to do this because Pygame already built this for me, right? The function, or sorry, let me rephrase that. The class that Pygame has built in that's supposed to replicate something like all bullets that I just demonstrated here is called sprites group, right? The exact terminology is actually a little bit different, but we're going to inherit from this class uh, to use this functionality, right? To be able to add a bullet into a sprite group, the bullet has to be of the same type of a sprite. Does that make sense? Think of it like an integer. How can Python add something if it's not of a type of an integer? Right, same concept here. So we have to change the type of what bullet is, making sure it's a version of a sprite. So we're going to inherit from pygame dot sprites dot sprite, capital S in the second sprite. This is going to give this class the functionality to work as a sprite. Now, what is a sprite, you may ask? It's just a fancy word that they use in game dev to represent like a character, right? Or an enemy, some kind of like NPC, right? A sprite is like a character, right? Really, that's the best way of explaining it. It is a character, right? So we are making our bullet class a version of a character, right? Like, and I'm talking like a playable character, right? So it's going to give it the version of this character that has the functionality that's going to allow us to manipulate it inside of a sprite group, right? That's all we're doing here. So to make sure we can actually use the methods that come from being a sprite, we have to initiate the parent class. And we've seen this already before. Super dot init. Oh, it's actually different here. No, actually, this should work. If it doesn't work, we're gonna come back and replace it with this pygame.sprite.sprite.init. If it doesn't work, but this should work. Passing self as well in here. Actually, do we need self? No, we should be fine. Don't pass this up. Okay. I think the documentation tells you to use pygame.sprite.sprite inits, but this should work the same. If it doesn't work, we'll come back and I'll use this as a replacement, but just keep this the same. We're essentially just initiating the attributes that come from the sprite group so we can use its functionality, right? That's all we're doing here. I think the documentation might be a little bit picky and it might recommend us to do this. So if we get an error, we'll come back to this, but it's nothing to really fret about for now. Well, this should work for now. Right now, we can treat bullet as a sprite and add it to some kind of a sprite group. So let's go ahead and navigate back to main.py. And I'm going to say from bullet, import bullet. So I can use this class. So I created the background. I created a spaceship. Let's create the bullet group. I showed you the demonstration of what it would look like if we had something called all bullets. Well, as I mentioned, we don't need to manually create this. We're going to use the method that comes from Pygame. And that method is going to be as follows. We're going to say self.allBullets is equal to pygame.sprite.group. This is doing the exact same thing as what we did earlier in my demonstration of creating that all bullets class, right? It's just allowing us to save it into some kind of object that we can call upon to update it. It's just saving us from having to manually code it. But because we're using the built-in function that comes from Pygame, that is the reason why the bullet class needed to inherit the property of the sprite. Because they won't recognize our class bullets as a sprite group unless we inherit from that, right? Because our class bullet is a custom-made class that we created, but we needed to be able to talk with the sprite dot group method. So they have to be like items with like items. But this here, this data member, as a matter of fact, let's print it out so you can see what this is. I'm gonna say self dot all bullets, and I'm gonna print it out. And let's see what it gives me when I run it. Oh, I put it underscore here. Okay, there we go. You see here? So when I ran this, it opened up my game, but notice that when I printed out all bullets, it says group 0 sprites. I wonder if I can put type. Let's see what it gives me when I say type. There we go. Look, when I print out the type of whatever all bullets is, it says class pygame.sprite group. Right? So this is the Pygame version of that all bullets class that I demonstrated. Right? It's already just pre-built. And I can show you here that it is a class. Right? But because this is a Pygame class, we also have to make sure that our bullet class is also a Pygame class. Make sense? All right. So with that already taken care of, we know what this is. We printed out what all bullets is. And as you see here, when I printed out all bullets, it told me how many items is in there. As it stands, there's nothing in here. It's an empty group. We created it, but there's no bullets in here, which is fine. Now, let's go up here. And what we are going to do is we are going to handle the functionality of actually shooting. So where we do that is going to be within the for event in pygame.event.get. The reason for that is because I want to use the mouse button. You could use the keys. You could look for a specific key for spacebar if you want to do it here, but I don't want to do that. I'm going to look for the mouse button event. So to use the mouse button event, I have to use the events that we're checking for already. We're already checking for the event for quitting, so we can just go ahead and add an additional event to listen to. So we're going to say if event.type is equal to pygame dot mouse button down in all caps. Pygame dot mouse button down. Right? We're just adding an additional if statement here. Actually, I think we can say elif. Because this, if we quit, there's no reason to have to keep checking here anyway, so it's fine. Yeah, we can say elif here. But here we're going to see if the event that is being called, if any of the event types that we have, are they equal to mouse button down? And if they are, we want to do something, right? So what I'm going to say is, actually, how do you think we should do this without looking at the readme? I'm playing my game. I click the mouse button down. Talk to me through the flow. How should this ideally work? Code-wise.
Do you want multiple bullets to fire while you're holding down the mouse click, or do you just want one?
Just one.
Then you could just call the actual bullet itself.
Okay, you're saying we're going to call the bullet class and create a bullet the moment the mouse button is down. Is that correct?
Yes.
Sure. Okay. Yeah. What does that bullet class need?
A location.
a location. What location should that be?
The front of the spaceship.
Right. So before we call the bullet class, do we need some kind of should we grab the location of the spaceship?
Yes.
Yeah, we should probably grab the location of the spaceship. We might have to do some manipulating, right, Daniel? Because obviously the spaceship location isn't going to match exactly where the barrel is at. So we might have to manipulate the y-axis a little bit. Maybe decrease it by like 50 pixels, maybe, to compensate for the size of the ship. Um, but yeah, so we're going to grab the position of the spaceship. We're going to then create an object for the bullets with the location of the spaceship. And then after the bullet's created, what do you think is going to be the next step?
Then updating the location for the bullet later on, I guess.
Yeah, yeah. I mean, you're not wrong. We're gonna add it to the sprite group, and we're gonna use that sprite group to update the location continuously as the game continues, right? But yeah, absolutely. So let's do that, guys. We're gonna say current ship location to grab the ship location. And we know that we have a method for that, which I believe is get position, right? It's going to return to us a tuple of the x and y axis. So we can say self.spaceship.get position, and this returns tuple x comma y, right? Next, we're going to create that bullet. We're going to create a temporary variable, Daniel, so we can save it somewhere. So we'll say new bullet is equal to, and then I'm going to call the bullet class. And we're going to pass in current ship location. I think, do we use index 0 or can we use .x? Now we'll use, since it's a tuple, we're going to say index 0 for the first argument. And then we're going to say current ship location, index 1 for the y-axis, right? Because it's a tuple, we're trying to access index 0 and index 1 of this tuple here. But we did mention that we might want to adjust the y-axis by a couple pixels. We're going to say right here for current ship location index 1, we'll say -10 to see if that fits exactly where it should be at. I don't know if it's going to be 10. We might have to subtract a little bit more. But this will create a bullet class for me. After the bullet is created, the next step is going to be to add it to our bullet object of all bullets, right? Our bullet group. So we're going to call self.allBullets. And to add it to the sprite group, you simply use .add. Where does this method .add come from, Roger? This comes from the class of sprite group, right? Because all bullets is a sprite group. This is a built-in class that comes from Pygame, right? So this is where I got this method from. So it's going to be .add, and I'm going to add inside this argument what I'm trying to add in here, and that's going to be my new bullet. Is this going to draw it on my screen, Dominic?
No, it's just gonna create it and it's stored inside your group list.
Yeah, correct. It's not going to add it to my screen. We created it and we saved it to some kind of data member, but as it stands right now, everything else that we've created, we still have to blit it onto some kind of surface. So we're going to do just that. Now, the way that you draw or blit something on a screen surface that belongs to a sprite group is different than everything else. We're going to call the group that we're trying to draw all the items from. So we say self.allBullets. And we quite literally use the command .draw. right? And we're going to draw on the self dot space surface, right? So you pass in the surface that you want to draw on. And now this should work to a certain extent. Let's go ahead and run our game. And here's my game. And when I press the left mouse click button, I see a bullet on my screen. Now it's not moving, of course, right? And I'm pressing my mouse button multiple times, but because it's not moving, I don't see anything. But I can probably check if it exists by printing out the sprite group. So let's do that. I'm going to say, after I add it to the sprite group, I'm going to say print self.all bullets. Right? I'm doing this within the event type. Right? So whenever I add a new bullet, I'm going to print out the sprite group to see how much is in there. Let me go ahead and run this again. And I want you to take a quick look at my terminal. Every time I create a new bullet by clicking my mouse, I can see that the size of my group is increasing. So I know it's creating multiple bullet objects. I can't visually see it because obviously they're stacked on top of each other on the same pixel location on my screen, but it's there, right? It does exist in code. I see a little smirk on Daniel. He's like, oh, this is cool. But let's actually add some more functionality. What's up, Daniel?
I think I broke mine.
Okay, yeah, sure. Let's go.
It's showing an error for like its location, but it's coming from the sprite group file itself, looks like.
Show me. I don't want you to continue without everyone being on the same page. Michael, Dominic, are you guys good?
I was trying to
All
get it
good
to do
here.
with the space bar, but it didn't seem to be working with that. So I'm gonna use the mouse.
Okay.
Here, I'll expand
Yeah, bullet object has no attribute rect. It's the line started in main.py on line 48.
Island 48. Let's see.
Let me see. You pass in self.space surface. Okay. You said self.all bullets dot add new bullets location. Okay. Let me see your bullet class real quick. X and Y self. Okay, that's where you probably messed up. You have to do self on line 9 before the self.image. You need to save it to a data member. So you need to do self.rect is equal to all of that. It's specifically looking for the rect. Remember I told you guys? I told y'all that Pygame is very finicky. It's gonna look for the rect. It wants that specific command. Try it now.
Let's see, click. Oh, there it goes. It's weird that it's like offset from the ship though.
Yeah, we're gonna have to fix that. That's okay. As a matter of fact, you can kind of mess around with it now if you want to get in there. Michael, Dominic, you guys good? All right, right on. Let's go ahead and continue. So we saw here that it was doing as it was supposed to. It's a little too high, actually. I might lower it by maybe like a couple pixels. And I am going to move it to the right. So I gotta increase the x-axis. So we're gonna say for into 0 plus 10, and let's decrease, or I guess increase. Oh, we need to make some more changes. Jesus. Okay, so I guess.
I think it's a plus 40.
Plus 40.
Plus 10.
Yeah.
You guys are reading the readme? Y'all cheaters.
No. I just
I
played with it.
100% I'm reading.
Yeah, there it is. Yeah, it's there. Thanks, Dominic. I appreciate it. What would I do last week? Yeah, so plus 40 and plus 10. And that got me dead on. Cool, cool. All right. So that's awesome, right? It's working. We have it in some kind of group. This sprite group class is able to track my objects for me. Now, it's cool and all, but it's not working as I want it to work. So we're going to give our bullet an update method very similar to how I showed you guys in the early demonstration. We're going to say define update. And all we're going to do whenever we call update is say self.rect.y minus equals 5. We're going to move the y-axis by -5 to make it go up. Now, how do we call this method on every single object? Well, once again, this is where the sprite group really shines. After we draw it, we're going to update. Actually, I think we're going to update it before. No, we'll draw it and update it. After we draw it, we'll update it. So we'll say self.allBullets.update. But you're like, wait a minute, Roger, you're calling the .update method on the sprite group, but not on the individual sprite. Right, so sprite groups should hold the same type of sprite object that have the same methods, and it allows you to call this method on that one object group, and it'll make every single object within it run the same method, right? That's really where this shines, the sprite group, which is why we're leveraging this group instead of having to hard code this, right? So by saying .update, it's going to pass this method into every single object that my group of all bullets is holding onto. And now when we run this, I see that my bullets are moving through my screen. So I'm able to repeatedly click my mouse. Let me do very quickly. And it's creating my sprites, right? And if I move left and right, I can see that it works as intended to. What do you guys notice though?
Zoom is probably only 30 frames per second because it looks like it's stuttering.
Oh, yeah, Zoom is a little slow. So sorry for Zoom. It'll look better on your computer when you do this. But what else do you notice?
Your sprite counter keeps going up. It's not
My
like resetting at all. So they
right,
just keep flying.
right. My sprite counter, it keeps going up, but at no point does it ever remove any kind of sprite that exceed my window, and that's no bueno, right? Especially when a game goes for a long period of time, whether you're playing this for 30 minutes to an hour, this sprite group is going to reach a very big size, right? It's going to start accumulating multiple different objects. So we're storing a lot of things in memory that we don't really need no longer because they're not even on our screen. They're outside of the window. So we need to be able to handle that. Well, in the same update method we created, we're going to say if self.rect.y is equal to, let's say, -10. -10, is this on my window or outside of my window?
Outside.
Yeah. Once it reaches -10, I'm going to run self.kill. Now, this method comes from the sprite group that we're inheriting from, right? Self.kill will quite literally just delete the sprite object, right? So if whatever bullet is currently at self.rect.y, it's going to delete itself. Now let's run this again. Notice my group and is actually decreasing because the current group count that you see here is what's on my screen. Everything outside my screen is disappearing. Do I have any questions? All right. So up to this point, we have a working spaceship with the ability to defend itself, right? We have this nice little outer space image. We have flight. We can move left and right. We can go up. We have our left and right limits as well as the maximum safe distance from where we can travel up to. But no hero story is ever complete without having some kind of arch nemesis, right? And in this case, for us, it's going to be our alien class, right? So we are going to create another file that we are going to use to create our aliens. So in lesson 10, say new file, and you're going to say aliens or alien.py. In here, we're going to import Pygame, just like everything else. And we are going to define our class alien. Just like the bullet, that we're going to have multiple different instances of this object, so are the aliens. So because of that, we also have to ensure that aliens are sprites as well, so we can handle them in a sprite group. So we're going to say pygame dot sprite dot sprite. Next, we're going to define our constructor method or init method. We are going to initialize pygame dot. Actually, no, we don't need that. We already saw we don't. We're going to say super dot init. I think that's how we did it. Yeah. The documentation tells you to use this, but as we just saw, we had no issues just using the regular super init, so that's okay. Now, in your assets directory, you're going to find 3 different aliens. You're going to have the green alien, the red alien, and the yellow alien. No game is fun if it's the exact same type of enemy. Therefore, we gave ourselves options, right? Now, how do we dictate when we create this alien object how this alien should look like? Should it be a red alien? Should it be a yellow alien? Or should it be what was the other alien? A green alien.
Green. You can do a random rand int and then put it 1 to 3, and depending on if it's 1, 2, or 3, it's going to create one of them. So that way it's just all random.
Did you read the readme?
No.
Yeah, absolutely. That's exactly how we're gonna do it. Right. So when we call an alien object, we're going to leverage the random module. The random module is going to give us a random integer between 1 and 3. And depending on what number we have, that's going to dictate which picture we're going to choose for our init method. So within our alien.py, we're going to say, we're actually going to import all 3 different images inside of here just to make it easier. We're going to say self dot, and because green alien is my first one, I'm going to say green alien is equal to, I'm going to load in the image. I'm going to say pygame self.image.load. And I'm going to specify the file path, which is going to be assets. Make sure you put the extra S at the end. Assets / and then the name of my alien, which is green alien.png. And then I want you guys to copy and paste this twice and ensure that you change the naming convention for red alien and yellow alien. Not just for the data member, but for the file path itself as well. We're going to load up all 3 data members. Next is going to be creating a data structure that can use index notation for us to choose one or the other. So we're going to say self.spawnable aliens is equal to self.green alien, self.red alien, and self.yellow alien. With this data structure created, we are then going to import random. Actually, we'll say from random, I think. We'll say from random import rand int, because that's really what we need. We don't really need all of random module. We only need the random function. After that, we're going to create the image for the alien object. So we're going to say self.image is going to equal to one of these 3 alien pictures, right? And we already have a data structure that we can grab them from. So we're going to say self.spawnable aliens. And then we're going to open up brackets to grab an index. And inside these brackets, we're going to say random. And we're going to say 0, 2. What's going to happen here, whenever the init method is used to instantiate the alien object, it's going to load up all 3 images. It's going to save them into a data structure of a list. And then when we create the image, we're going to choose a random index from this list to grab one of these pictures to actually use it as our image. Finally, we're going to say self.rect is equal to, we're going to grab the image and say .getRect. Right, so we need self.image.getRect, just like everything else. And how do I want to grab them? I guess top left. Yeah, we'll say top left is equal to 0, 0. This has to be in parentheses. That way we can grab the top left of this alien and put it in the top left corner of our screen. So everything else, everything from line 14 into or before line 14, it's really just us figuring out what image we want, right? Loading in all 3 images, choosing one, and then we're actually going to save the image into some kind of variable like image, and then we're going to give it a rectangle, right? No real change really compared to like the bullets. Now, when we just created, let's go ahead and navigate back to main.py. We're going to import from alien, import alien. Just like we created a bullet group, we're also going to create an alien group within the init method of game. We're going to say self dot all aliens is equal to pygame dot sprite dot group. Right, this is a unique group just for our aliens. And we're going to take a quick pause here and go on our first 10-minute break of the night. I will see you guys at 6:43.
You're muted.
Oh man, I hate when I do that. I'm like so into it, like my welcome back, guys.
Rookie mistakes.
Oh Lord. All right. Well, welcome back. We're gonna go ahead and continue from where we left off. I mentioned, we created here our all aliens group where our alien instances are going to be going to. Now the next thing that we are going to have to talk about is how are we going to make these aliens appear, right? Should they just all come out all at once? How do we make sure they come out at a certain time? Well, we're going to create a customized event, right? We've seen events already. We saw pygame.quit and we saw pygame.mouse button down, right? But we want to create an event very similar to that. In this event, is going to be the spawning of our aliens, right? We're able to create our own custom events if we wanted to. So to do that, we're going to say within the init method of our game class, we're going to say self dot enemy spawn timer, right? And this spawn timer, to make it into an event, we're going to say pygame dot, and in all caps, we're going to say user event +1. Now, don't ask me why we have to add +1. I feel like it's a little weird. Pygame apparently, the way that it tracks that you want to create a new user event is you have to call the command user event and then say +1. I don't know how it works this way. This just how it wants it. All right, this is from the documentation. Other people working with it, so just trust me on this one. All right. So we're gonna create this custom spawn event, right? This is gonna create literally an event like pygame.quit or pygame.mouse button down. But our event is called enemy spawn timer, right? Now, after the event is created, we're going to actually set this timer by saying pygame dot time dot set timer. And this timer is going to trigger our self dot enemy spawn timer event. And I want this to happen I think I don't get to choose. I think that it's every 1 second we could do it. We'll set it to 2 seconds. I believe this should work. I think that last time they gave me some weird functionality. Let's just double check real quick before I give you any wrong information. We're gonna say pygame.time.set timer. It's always good to always check the documentation with anything that you might be a little unsure of. So here is the pygame.time.set timer. It sets an event to appear on the event queue every given number of milliseconds. Okay, cool. So the milliseconds, how much is 1 second? How many milliseconds is 1 second?
1,000.
1,000. I was right. See, why do I doubt myself? I shouldn't be doubting myself. That's not me. Yeah, so we're gonna use 2000 milliseconds for for 2 seconds. Right, so the set timer takes the event and uh when we want it to trigger. Every 2000 milliseconds, for every 2 seconds is gonna be a new alien. Right? That sounds about right. So this creates this user event. Pretty much it's like setting like a boolean, like self dot spawning aliens is equal to true, right? We're pretty much just saying, uh, are you spawning alien every 2000 seconds, right? That's kind of what we're doing here with this user event. We're just creating something that we can track, and we want to happen. That way we can call upon this. We can say, hey, every time that this event happens, which as we already saw here, we're set it to happen every 2000 milliseconds. I want to do something. So this just gives us a reference point or a condition to create an alien. Does that make sense? That's what we want. And Pygame is going to manually run this event every 2000 milliseconds. So with that in mind, we're going to track it as an event. We're going to say, let's remove the elif, make this back to an if. So we don't get any weird functionality here. And I'm going to say if event dot type is equal to self dot enemy spawn timer. And you might be asking yourself, Roger, why'd you remove elif? Shouldn't it be elif? Since we're chaining these together? No. What can happen if I say elif here and I say elif here and I have other elifs instead of just using ifs?
It'll
Only
skip over one of them. Like, say
Right.
you click the button, it won't spawn an enemy.
Right. What if an enemy is supposed to spawn at this exact moment as I click my mouse button down? It won't actually spawn an alien until another 2 seconds later. So there'll be a 4 second gap between my enemy spawning, right? So I don't want to make sure that these are elifs. I want all these to be able to have the same chance of happening at the same time, right? So we're going to set all these to if. This one really doesn't really matter. We could probably set this check at the very end, because this, if this one passes, then obviously nothing else is passing, right? Because we're quitting. But yeah, we want to make sure these are if statements. And then here on the event type, we're checking for the spawn timer. And when this spawn timer happens, we should be creating an alien. So we're going to say new alien is equal to our alien object, which, let's see, how are we doing this? We set it to 0, 0 already. We didn't pass in any kind of argument, which is good, right? We don't want to give it a customizable argument because we don't need to. Every single alien should spawn at the top left corner of my screen. Now, if you want to randomize where to spawn, that's going to be up to you. I ain't doing that. We're keeping it straight, simple, like from top to bottom. They should work or snake their way down, right? So our alien should take no arguments and it should create an alien. Finally, we're going to say self.allaliens.add new alien, which is going to add it to our alien group. Once the alien has been added to the group, that's it. We don't need anything else to do for now. Let's go ahead and move downwards. And after I draw my bullets, I also want to draw all aliens onto my space surface. Now, obviously, we're missing something here. As you can probably already tell what we might be missing, but that's okay. We'll handle it in a bit. After you do the draw method within your while loop, I want you to run your game. And you should be able to see in the top left corner your aliens spawning. They will be of random colors. right? If you see a color stay there for a while, it might have been just the randomness, the fact that it might have landed on the same one twice back to back or 3 times back to back. There's a 32% chance for each one of these. Right, but here's my aliens. They're spawning. They're appearing on my game window every 2 seconds. My event is running every 2 seconds. Therefore, creating an alien every 2 seconds, which is being added to my group, which is I'm drawing on my space surface. Cool. All right. What are we missing here? Movement.
Update feature for movement.
Right, an update movement, right? Absolutely, just like Danny said. We want to update our aliens. So within our alien class, we're going to return and we're going to give it an update method, right? We're going to say define update and how do we do this? Let's go with self.rec. We'll just keep it simple for now. Self.rec.x plus equals 5. We'll keep it really simple right now and see how this works. And then we're going to return back here. I'm going to say self.allaliens.update. And now, spawns by aliens and it starts moving. A little too fast, I may add. I think it's a little too fast. I feel like they're spawning a little too late for my taste. So let's fix that. Let me lower this from 2000 milliseconds to 1. And let's see if it increases its spawn rate. Yeah, that's a lot better. Now let's do 500. Yes, sir. That's what I like to see. Now, we have an issue. It's not really doing anything. They're going to the far right out of their screen and they're leaving the screen. And that's no bueno. So here is your first assignment of the day. Your challenge is to fix the movement of our aliens. What should happen is the aliens should be able to move from top left all the way to the far right. Once it reaches the far right limit, it needs to shift downwards and then change direction and move left. Once it reaches the far left limit, it needs to shift downwards and then change direction and move right. Mimicking the snake pattern. It needs to snake its way all the way down towards us. The movement needs to be handled within the alien class. You guys got 10 minutes. All right, so as of right now, our game has our aliens exceeding our window. So let's just go ahead and stop them from moving all the way to the far right. We don't want them to move right if they reach a certain limit. So we'll say if self.rec.x is less than or equal to, and I think we can go with like 750. Then we will increase it by +5. And let's see how that works. Hey, that's pretty good. That was spot on. 750, right? That stops them right there. So it keeps them from moving, which is exactly what I wanted. Now, if self.rex is equal to 750, then we need to shift down. So how do we do this? We are going to set a Boolean that I'm going to use to reference whether I am moving right or moving left. So I'm going to say self dot moving right. Am I recording? Yes, I am. And I'm going to set this to true. So I'm going to say if moving right is equal to true, self dot moving right, then I want to uh move it to the right. I don't know if I should change this. So I say if self dot moving right is equal to true and self dot rect dot x is less than and equal to 750, then increase it by 5. Let's see if we could just chain it. Yeah, we'll keep it like this. If it's moving right is equal to true, then we'll move to the right as long as it's less than 750. Actually, let's not chain it because I want to check for the 750 as well. But if it's equal to 750 already, then I need to shift down. Maybe it's better if I do less than 750. Make sure it doesn't affect it. Give me a second. Let's see, 750. Yeah, it's not as close as I want it to be. Let's start 755. Yeah, that's where I want it. If it's less than 755, I want to move to the right. But if it's 755 or greater, then I want to increase my y-axis. So I'll say self.rect.y plus equals, let's go with 10 for now. I'm going to shift them downwards. And I'm going to say self.moving right is equal to false. So the next time this runs, it will not move it right any further because it is no longer true. So if it's moving left, right, if moving right is equal to false, that means I want to move my x-axis -5. Let's try that. So it goes right. Oh, shoot. Never mind. I moved it up. I need to do minus equals 10. Let's do it again.
No, it's your else function.
Oh, my bad. I want to increase my x. Now decrease my x. My bad. I'm all over the place. Sorry, I'm a little tired. I want to decrease my x by 10. No, by 5. 10 is going to be way too quick. Let's try it again. Yes, sir. Okay, it's doing what I want, but I need to shift more. 10 is not enough. Let's go with 20. So it goes to the right, it reaches the limit, and it shifts downwards. 20 is not enough either. Let's go to 30. Is that too tight? A little bit, maybe? I think that's like spot on. I'm gonna leave it there. I think that's spot on. Okay, awesome. Now, obviously, we just saw that once it goes to the left side, it exceeds this left side. So we're gonna say if self.rect.x is greater than, let's try 45. We're going to move it to the left. Else, we're going to say we're going to increase the y-axis again. Plus equals 30. And we're self.moving right is equal to true. And this should complete the loop. Let's try it out. Oh, okay, it's good, but this is not where we wanted to. Let's reduce this by a lot. Let's check the, let's make the Y be to 10 pixels. That's pretty good. I'm going with 5. I think 5 is right where I want it. It gets as close as it can to the window. Yes, sir. There we go. Okay. We got liftoff, boys. So as this continues, we use a Boolean to track what direction that we were moving. By default, as we saw here, we started the top left, so we should be moving right. So we said moving right is equal to true as we start. So if we're moving right, obviously, then we need to increase our x-axis, but we also have to set a limit so it doesn't exceed the right limit of our window. So we say if self.rex.x is less than 755 pixels, then we can increase our x-axis. And only then. But once it does reach 755 or greater, which it will equal 755, we need to shift downwards and change directions. So in the event that our x-axis is equal to 755, we shift our y-axis by 30 to the positive side. Said moving right is equal to false. So then the next time the update method is ran, this if statement does not pass and we default to the else statement. And now we change the direction of where our x and y's are going to. But overall, it just restarts this loops, and now we have this cool looking pattern. I don't know if you guys can see it, or if Zoom just doesn't help it or give it any justice, but it looks pretty cool. It looks like a wave back and forth. But yeah, so now we got movement, right? And this is kind of how it should be. This is what I expected. Let's go ahead and close this out. So that's going to, essentially conclude the movement of our aliens. Now, we're close to the finish line here, but we have an issue, right? When I run this, although I have an alien, I have movement, and I can fire, nothing's happening, right? So the aliens don't disappear, and actually my computer's lagging a little bit. My laptop's not a gaming laptop, so it's a little slow. But also the aliens don't kill me when they touch me. I can't lose. I'm him, right? And we gotta change that up. So how do we do that? Well, what we're going to do is we're going to update our class for our bullets, right? As well as our aliens. We need to make sure that we're able to kill them off the moment that they are no longer needed, right? So how do we do that? Well, in our bullet class, we're going to make some changes here. We're going to pass in a new parameter within the update method. And this is going to be alien group. So this is another reason why we inherited from pygame.sprite.sprite, right? Because we can leverage the fact that we can compare two sprite groups to each other and check if any sprites in one sprite group collide with another sprite in another sprite group. Now, we could definitely do this with code, but it would have just been a little bit longer, and it wouldn't adhere to the rules of like not repeating ourselves. Like if we have the ability to do this with a built-in function, Why not just do it? So the way that we're gonna do this is when our bullets are flying and we're updating them, we want to check the bullets to see if any of them have made contact with anything inside the alien group. So we're gonna pass in the alien group here as an argument. And what we're also going to do is we're going to check if they collided or not. Now, how we do that is by a very simple command. Between the movement of the y-axis of our bullet and before the kill method, we're going to say Pygame dot sprite collide. And in here, we're going to pass in what two sprite groups we want to compare. We're going to say self, which is going to represent the bullet that is called this method. And then we're going to say alien group, which is the argument we're passing in here within the update method. And then it's going to take a Boolean as a third argument. This Boolean represents what you want to happen when they collide. Now, where did I get this? We can check the documentation so I can show you. Pygame.sprite collide. Here it is. Sees if the sprite block has collided with anything in the group block list. The true flag will remove the sprite and the block list, right? That's why we're doing it the way that we're doing. We are passing in this command inside of bullet because ideally we want the alien to disappear the moment it collides with a bullet, right? So let's do that. We're going to set this to true. That way, when the bullet collides with an alien, the bullet gets destroyed. I'm sorry, not the bullet, the alien gets destroyed. Now, the only thing we need to update now on our main.py is we need to pass in the alien group into our update method for bullets. So we're going to scroll down to all bullets, and we're going to pass in self.allaliens. And we should have working colliders. Oh, no. I am missing something. Oh, this is supposed to be my update method. My apologies. The update method. Self.allaliens. There we go. And there we go. We now have the aliens being destroyed by our bullets. They're not spawning fast enough. Let's increase their spawn rate. They shouldn't have given me this power. There you go. Yes, sir. Straight to the meat machine. Awesome. Let's go ahead and close it up. Well, it's way too many. Yo, hold up. Hold up. Get out of here. All right. Pretty cool. All right. Now, that's working, but there's another issue that we have not been able to take care of. As you see here, as the aliens come through, what happens if we start getting overloaded, which will happen? We need to make sure that when they come down here and they come in contact with our spaceship gets destroyed and we lose. I don't like how close they are to each other. It takes forever for them to come down here. Let's go ahead and increase that. We're gonna say for them, we're gonna increase their Y by 50. We're gonna say 50. There we go. But we need to make sure that our spaceship is able to be destroyed as well. So the way that we're gonna do that is we are going to navigate to our main.py. And in our main.py, we're going to check where, I think we could do it down here. Let's see. Let me check my notes. Yeah, okay. Down here, before the update method, but after the drawing of everything on our surface, we're going to say, I believe pygame dot. No, we'll say if pygame dot sprite collide. We're going to say self dot spaceship. We're going to pass in self dot all aliens, and we're going to say false. But all we're going to do is we're going to manually quit the game using these commands. And we're being a little lazy with it because I don't want this lesson to last too long. But if in the event we collide with an alien, I want my game window to close. That's going to let me know that I have lost. If you guys want to increase how, uh, what you call it, how to handle when you lose, then you guys can fix that on your own. You can add more functionality. But what this does is it completes my game loop. It gives me a way to lose, right? Games you need to have a game loop. You know, from start to finish, you start, you do this, and then this is how you win or this is how you die, right? That is your complete game loop, right? And that completes it. And congratulations, you have completed your very first game. Do I have any questions on Space Invaders using object-oriented programming? None at all.
No question. I had a blast though.
Oh, I'm glad you guys have something to work on. Show this to your kids. Uh, yeah, I mean, play around with it. You guys can mess around with it. We're gonna do a couple more exercises with this. The one that we're going to do is going to be exercise 3. We're going to add music and sound effects to our classes. Because right now, as it stands, it's pretty bland and boring. It doesn't really do anything for us. Games and really anything, whether it's games, shows, right, movies, you don't really think about it, but music makes or breaks a game, right? Some games, they're iconic by their soundtracks, right? Think of, Super Mario Bros., right? The soundtrack of Super Mario Bros., everyone knows that. If you hum it, everyone knows that that is Super Mario. Some of this music, some of these sound effects are so iconic. The music really does it for you. For some shows, anyone watch the Devil May Cry show on Netflix? They came out. Great soundtrack. Anyone watch? I don't know if you guys like weird stuff like anime, but did anyone watch Kaiju number 8? Kaiju number 8 goes pretty hard, right? It had a great soundtrack, but the soundtrack like really does it. Like some of these fight scenes, like really does it. But we need some kind of music, right? It would be nice to be able to have some kind of background music or have something to let us know that we're firing, right? Because this is way too bland. So I'm actually going to walk you through the adding of the music and the sound effects for our class. And I'm actually going to pause this recording because I'm going to mess this up a lot. So it's going to be a lot of us going back and forth, checking through the documentation, and us working through it. And once we're done with here, I can come back to you guys because this is not like I mentioned before from the very start of this lesson. This is not a Pygame lesson, so I'm not going to sit here for an hour and a half showing you how to work with a Pygame methods. So I don't want to have it on the recording and waste people's time. So I'm gonna go ahead and pause the recording right now. So just for the sake of getting this on recording, so we set up our audio here. We have 3 lines here. We set up a channel, which we were going to essentially like run or stream our music on. using this command. We saved it to a self.channels data member. We then loaded in our music file using this command here and saved it to self.background music. And then finally, we call the channel we had created, not directly, but the channel essentially does exist when it is saved into channels, but we're essentially accessing that channel that we created at channel 0, and we're playing the background music. And then for the sound for the spaceship shooting, we added that to the bullet class itself. Inside of the init method, we create the data member for self.shoot sound. We use the mixer.music.load to load in the music file, and then we have the dot play function for the pygame.mixer.music. Right, this is going to run when the bullet class is initialized, which should work when we shoot. The bullet is created, therefore the sound is made, and then the rest is history. That's going to conclude that. Here, a quick demo. I think I'm still sharing with sound. It's going to be a little too loud, so I won't play it for too long. But this is what it looks like. Final product. The sounds that we got were gotten from Pixabay. You know, I'm not monetizing this project or anything. So we're just using some free music snippets here. Pixabay was pretty cool. We're able to get music and sound effects. For the music, we got 8-bit retro, I believe was the prompt for it. And it gives you the 8-bit retro game music here. This is the music sound I'm using. And then for the sound effects, I just put laser blast. And really, you can use whatever sound you want. I want to say I use retro laser 1. Yeah, this is what I use for my sound effect. By Dricken5482. This is where we got the sound effects from. Really, it just downloading it as an MP3 file and adding it into a directory in your folder, and you should be good to go. Now that will conclude today's class on Space Invaders object-oriented programming. If you guys read through the README, you would notice that it's not the best written. I wrote this a long time ago, and it was over a weekend when I was just kind of brainstorming, like, how can I do something for the students? I think I was like in the middle of an FOP session, and I was like, we have some free time. I want to show something to the students that could be fun. At the same time, incorporate everything we've been learning so we can better visualize our work. So I wrote it up in an afternoon. This was the product. So I apologize if it's not the best written. Just review the videos to make sure that you have the most up-to-date code. And here we have some exercises that you guys can work on. We did exercise 3, which is adding the music and sound effects to our classes. To give it a little bit more ambience, make it feel like a real game. And that way, for those of you who have kids, you guys can just kind of let your kids play with it and be like, "Hey, look what Dad made!" Right? They eat that up. If you guys want some additional work over the weekend, definitely try doing something like adding a scoreboard. Right? You should be able to kind of write on the screen, add some text that can keep count of how many enemies you've destroyed. Which shouldn't be too hard. Honestly, just kind of creating some kind of variable that keeps track of every time that an enemy is killed, right? The code is pretty much already set. It's just adding some additional functionality. You can also give the player lives. So maybe download a picture of a heart, think, let's say, Legend of Zelda UI. What's an old one? Legend of Zelda. Temple. No. Ocarina of Time was one. Right. Think of Ocarina of Time. Right. Look at the hearts being retro style. You can probably maybe download these hearts here. Find like an image of these hearts. That'd be pretty cool. Have like 3 or 4 or 5, and then every time that you're by whatever reason your spaceship gets overwhelmed, you take damage, therefore you lose a heart. Something like that can be a nice feature that you can kind of mess around with. Um, Another thing that you could probably do is work on power-ups. Create a new object for power-ups specifically, right? That can either make you go slower or faster. They can increase the attack speed. Uh, how many bullets are released, how fast your bullets travel. You can use like as time elapses, the speed of the alien increases. So maybe set create a timer in Pygame. We talked about setting events. Uh, you can maybe trigger an event where the create like an enemy level up, right? And you trigger it every 60 seconds. So that'll be what 60,000 milliseconds on the user event method that we use. And every 60 seconds, the enemy gets double the speed, and then double the speed, or something like that. Increase it by a certain amount. So the longer you last in the game, the harder it's gonna get. You can do something like that, right? So mess around with it, create some power ups if you like, and whatnot. I think it'll give you guys something nice to work on over the weekend and continue working with objects, and so on and so forth. But besides that, that's going to conclude today's class. Next week, starting Monday, I believe we close the curtain on object-oriented programming. And we're going to move into data structures and data algorithms, which is probably not the most sexiest part of our course, but it's definitely going to be helpful to review and cover, so you can, practice on lead code challenges. We're going to talk about bagel notation, time complexity and space complexity, being able to identify what good code looks like and bad code, right? One of the things that you might get in an interview when you go to apply for a job is they're going to ask you, like, what is the time complexity of your code? Or what is the time complexity of this? And it's big brownie points if you're able to talk about the time complexity of your code as if you know what you're doing, right? So it is a junior level question that they will ask. I've had it been asked before. So they might ask you, like, what is the time complexity of your code right now, and how can you make it better, right? So knowing how to differentiate from good code and bad code, or okay code to better code, right? So it's going to be very important. We'll definitely do that next week, and whatnot. But besides that, I'm going to go ahead and stop the recording now.